Welcome back. So in this lecture video, we're going to go over a data structure, very basic data structure called a random bag. Basically implements a bag that you pull things out of randomly. So first, let's go through a few things about C++ classes. And this example is going to be used to implement in two pieces and go over how C++ classes can be implemented in two different files. So as we can see here, we have a few notes to start off with. And so defining a C++ class usually is in two steps, the header file and the implementation file. In the header file, we have all of the descriptions of the operations for the class and what we can perform in that internal state it needs. And so these are typically .h files. And so we name the class name .h. And the implementation file contains all the definitions for our functions. And so the actual implementations of the functions would go in this .cpp file. And so we have those two files, and then we want to include, if we were writing a third person or third party or ourselves, we're writing a program, all we would have to do is include the header file in our program, and we get access to that class. And so we can use that class. And so, so this is implemented within two different files, a CPP and a header. And as we go through and we think about discussing data structures, we are often going to implement them without templating. And so when we template, we'll often go back to that single file implementation. Okay, let's get right into it. And so we have here our two files, our CPP and our .h. The first thing we will write is our .h file. And so we want to talk about our class implementation. So class, and we often will name it random bag. So we want random bag. And so our capitalization there should follow the style for C++ or the style that you are required to use for where you're implementing. And so our class random bag always will have that basic class keyword and then the name of the class. And then we have our curly braces and the semicolon. And so we can also set up our basic setup for our public and private areas. So we could have our private area and then our public area. And sometimes we will have a protected area. So I meant to type protected here. And so we see that protected area, we won't use this much in our implementations, but the protected area simply is allowed when you're within inherited class. We can access data members directly. For this implementation, we're just going to use private and public. That's our basic setup for a class. And when we include something, over here we see on our CPP, we included random bag.h. When we include it, we don't want it to be able to include it twice. We don't want duplicate implementations or compiler errors complaining about duplicates. So what we have to do in more recent compiler, we could say pragma once. Oh, pragma once. And so that's what we would do, and now that will only be included once. In other systems, we have to use our if and def, and then we often will capitalize our random bag, so random bag, and then underscore h. And so that says if this variable is not defined, and then we go into this if statement and we define it. And so that way we have it defined here. And so the next time, so every time the first time it includes, it'll say, does this variable exist? It does not. So we're going to define this variable value, this key value. And then at the end, we would have our end if, and that just ends the if statement. And so the second time through, this variable will be defined. And so we have this being false and we skip the inclusion. And so that prevents us from including all of this code multiple times, whatever exists in this class definition or class .h file. And so that is how we can prevent that from happening. So let's go through some of the pieces of our .h file, starting with our public functions. So we're going to have 4 public functions. We will have first a insert, so we have to be able to add something to our bag. That means it's a void function because we won't get anything back. So we want to insert into our bag. We just can call it add. So add something to our bag, and we are, like we said, we're going to code this as integers. So our integer n is going to be added to the bag. We could also add a random number to the bag, but we won't get to that. We'll just add this one number that we've specified. Then we want to be able to remove something from the bag, and it's going to be removing a random from the bag. So that's why it's a random bag. We just want to remove an integer. So remove random. It will take nothing because it's just a random element that we are going to remove. And so then we have 2 other functions, and they are often seen in lots of data structures. That we have the isEmpty function, and that will return true or false based on whether the bag is empty. And then we have our size, which is just going to return an int. So it'll return an int and size function, and that will be const, and this other one should also be const. And so what const does there is prevents isEmpty and size from changing the data members. So like it cannot change any of the information. It can only access the information. So nothing will be changed by calling those functions. These other 2 modify the bag so they can't be constant. And then finally we need a single private data member or data field. We are just going to use a vector for ours. So vector of integers and then call it bag. And so we have our bag that contains a vector of integers, and we will implement that bag. We can just say the elements in the bag. Let's just call it elements. So the things that are in the bag, the elements. Now we have this random bag. We have all of the parts defined, but we haven't actually implemented any of these functions. But anyone that saw this header file can say, okay, this is how I interact with the random bag class. So if I have a random bag object, I'm allowed to add something, remove something at random, check if it's empty, and check the size of the bag, which is how many elements are in the bag. Okay, so the last thing to note here is we have to make sure that all of our items that we need to include are included. So we have a vector of elements, so that means we need to include the vector library. And so that's the end of our header file. So now with our CPP file, what we're going to do is implement each of these functions that has been defined within our public area. And we have to implement those so that the public, whoever's using our class, creating random bag objects, can actually call functions. Okay, so let's get started. We're doing random bag. So we would want to actually include our random library because we have to implement some sort of randomness into it. So we're gonna use the rand function, and then we will go about implementing each of these functions. So let's start with the size. That's the easiest. Our isEmpty also is fairly easy, but what we have is an integer return type, and then we want to be in the random bag class. So we have random bag, and then we have to say, okay, we are a function that is defined for the random bag class. So we use the scope resolution operator, and then we put size here and also const, because that is how it's defined in our header file. This size function return the size of the number, the size or the quantity of the number of elements, so we can access our local variable, or rather not local variable, our private data member, and return the size of that vector. And that's how big the random bag is currently. Now, if we think about the isEmpty, what we can do is return a true or false. Again, we need to have our class name followed by our function name. So our function name is empty, and it's a constant, so it can't actually change any of the values in the data members, the private area. And so now we're just going to return, oh, I forgot the return statement up there. We're going to return whether we are a size 0. So we're just going to call size and compare it to 0. And so size here calls this function within the random bag class. And then size within size calls the elements, the member function of the elements object, which is a vector member function. And so when we're designing classes and implementing classes, we want to use the functions that we've already written. So we're not reusing the same code in different functions. We should call the functions that we have. And so if those are 2 of the 4 functions, and now we can implement our add function, which is another fairly straightforward one. Takes an integer and we'll just call it n. Again, we didn't actually need the variable over here. It just takes an integer. Sometimes it makes it more readable if you include the variables with the prototypes, but this right now is just a bunch of prototypes for those functions. So in a prototype, you don't need the variable name. When you're implementing the function, you need the variable name. And so we have to have our scope resolution operator to state that we are in the random bag class, and then we will implement our add. And so our add simply is going to add something into the bag using the pushback operator for the vector class. Okay, so like I said, we're going to use the vector class. So we have to get the object, and then we're going to push back our value that has been provided. And so that's all the random bag add's going to do. We could also invent something that's just add random, but we usually know what we're putting into the bag. We just don't know what we're pulling out. And that's how a random bag works. And so the last thing we have to do is implement that remove random. And so that's an int, and then random bag with our scope resolution operator, and then remove random. And so we have 2 things here that we have to implement. We have to acquire that value, but we also have to acquire it randomly. We have to first determine a random number, and we're going to use rand there, and we're just going to mod by the size. And so size gets us how big the bag is. Rand gets us a number between 0 and the integer maximum that's set for our system. And then mod allows us to create a remainder between 0 and the size, not inclusive of the size. So 0 to n minus 1. And that allows us to create that number, that r value. Now to get the value from the bag, we simply want to store it. So val equals our elements dot at r. And so we're using our vectors at function to acquire the value at position r, and then we will eventually want to return that value. But we also have to remove it from the bag. So now we just acquired it and we're returning a random thing, but it's still in the bag. So we have to erase it from the bag. So we can call elements.erase, and we want the specific position of where that is. So we take our elements.begin and then also our r. And so we have that, our index. So the process we think about when we erase, our randomness, our random number generator gets called, our elements at r uses that random number, and we acquire the value. But if we did this afterwards, or if we simply acquire the value and returned it, if we just returned it right away, we would not be erasing it from the bag. We would not be removing it from the bag. If we erased first, our index r now points to something else in the bag because we've erased that. So that doesn't work either. So we have to store the value we want to return and then erase it from the bag. So one thing to note is that this doesn't do any error checking. So if we wanted to do something, if is empty, throw some error, there's nothing in the bag, then we can throw some error there. Most data structures allow you to remove and not handle this error checking. They allow you to pull off the front of the queue or the top of the stack even if it's empty, your program might crash, but they don't throw an exception. So they don't handle that in the standard library implementations. So let's go about using our bag. Okay, I have one error to correct here. This is supposed to be a plus, not. So we take the offset from the beginning. We're calculating the offset from the beginning of the vector. And so we're just going to create a random bag. Then we're going to output the size of our bag. And then we're going to insert into our bag. So add something into our bag. We will just input into our bag the numbers 1, 2, and 3. So we can't actually see what's in our bag. Once it's in there, because we can't look through it, there's no way to search through our bag and determine its contents without removing all of the elements. Similar to a stack or a queue, we can't actually go through without just removing everything, and then we will know exactly what was in the bag. We just don't know if we gave someone a bag. And so now we have 3 things in, 1, 2, and 3 we put in, and we can output again our size. And so we have our size, and we will now go through and randomly remove until we receive that empty. So we can go through and say, while our bag is empty, and we actually want to be not empty, we can go through and output our items that we pull from the bag one at a time. So cout our bag.remove random. Okay, so we have our remove random and our bag here, and we're just going to remove a random item from our bag. And we go about then printing the size. Maybe we'll print the size too. That would be useful. Our bag.size and an inline. Okay, so we have each of those, and we keep looping until our bag is empty. And so every time we remove something, it should reduce the size by 1. And so let's go about compiling some of this and making sure that our code works. Normally, you should probably compile a few times as you go about your implementation. Okay, let's compile our code, and we cleared everything. Let's compile. All right, we got a few errors. Let me see here. Vector's not a type. Let's see. Okay, so we need to be in the standard namespace there. We aren't using a namespace, so we need that std::. Let's clear again and see what we get. So our error is not defined here in random bag CPP. We actually need to throw our error, but we're just gonna switch it up a little. That's me thinking in C more than C++. So we're going to throw something to CArr, our console error, and we're just gonna output that. So if we try to remove random, after that point, it will cause problems. And so again, we need clearing out some of these errors might help. Again, what we're missing in a lot of places is the namespace operator and compiling. And so now we've compiled successfully, and so we've compiled our code, and let's just execute it right away and see what happens. And so we entered our bag size, we 0. We added 1, 2, and 3, so our bag size is now 3. And then we get our 2 is pulled, and the size is 2. Then 1 is pulled, and the size is 1. And then 3 is pulled, and the size is 0. So we pulled out 2 first, and then we pulled out 1, and then we pulled out 3 in this implementation. And so if we try to do again, cout bag remove, I'll just copy this code here. We should see our error, and we will clear, compile, and execute. And so now we've seen our error. Outputting the standard error and not returning is not a good idea. And so we're going to return -1. We should be throwing some sort of exception. We tried to do a bunch of stuff after it was empty. That doesn't work. And the system threw a core dump for us and said, you did not handle that error correctly. So again, this is often the implementation you will get in a lot of standard library. So a lot of STL containers you can remove even though it's empty. You can pull off the front or pop off the top, or do something, and it will sometimes work and act okay, meaning it doesn't crash your program. Other times it will crash your program. And so we would want to return from there immediately, and then now we would simply get -1, which isn't the most clean solution, but we got that back to where we wanted to go. Okay, so we have that. And so this has been implementation. So let's look back here. We've been implementing and using our random bag object, most basic data structure we can have, and we've gone through and implemented in 2 different files. And so we can go through and combine these into one file, and in that case, we would implement inside our class. And so we'd take something like our add, and we, instead of having it in our definition, we would go through and implement entirely inside the class right here. And we not call it add, but add. And so we'd end up with our implementation inside, and that's how we could trim it down from 2 files into a single file. Thank you for watching.